Okay, so good evening, everyone. We can start. Okay, so first of all, tell me, everyone, how was the test? Like, how was the paper?
It was good
That's
this
good.
time.
Okay,
Yes.
yes, I saw your scores. It is good only, but little bit more marks would have been better. Okay, people have scored more than this. Okay, so I was expecting more from many people. Okay, Shashwata is still giving the test, I guess. Shashwata, are you giving the test?
So I have finished. I have submitted.
Okay, okay. Then let me see the score. Have you seen your scores?
It's a bad.
Bad. Why bad? Should have been better. Better than the
Sir,
previous one.
my score could have also been better, but I didn't have much practice this time.
And Adrija also, you should have given better. I mean, you should have done better. I mean, it's okay, but I was expecting more. Okay, Adrija.
Yes, sir.
Okay, and others also. Adrito, Madhurjo, you have to improve. Try to understand. Ronak also. Hello, Ronak, can you hear me?
Yes, sir.
Okay, let me see Anvesha. Okay, Anvesha, your score should improve. Try to understand. Okay, this is not the kind of score I'm expecting. Okay,
Yes, sir.
should have been better. Let me see. Shashwato, is it okay? Oh, Shashwato should have been more. Okay, are you getting? Should have been
Sir,
at least
I was
five,
only having problem in one question. I thought I would get 4 marks less.
4 marks less. Then this is way much. This is like you have lost a lot of marks. Considerably more
So
marks
I
you
was
have lost.
feeling comfortable while solving other question, but I don't know how they got
Okay,
wrong.
let me see. Let me see. Okay. I'll send you the evaluation. Okay, go through it. Okay, if there is a, I mean, you see that there are, I mean, there are some discrepancies. Let me know. Okay.
Okay, sir.
Next, I think Abhigyan is also submitted. Oh, Abhigyan, you have to improve. What have you done? Are you like, I mean, is the chapter not clear to you? Ellipse and hyperbola. Tell me, is the chapter not clear to you? Hello, Abhigyan, can you hear me? Oh, he's not there. Okay, Pratyay, this is good only, whatever you have done. Okay, you didn't do the class, but still, this is a good score. Okay, as per your ability. Okay, but this is not the kind of score you, I mean, this is not the kind of marks you have to score. Okay, you have to improve. Are you getting Pratyay? As
Yes,
the day
yes.
goes by, okay, you have to improve yourself. Okay, by 20 marks at least. Okay, whatever you have got, okay, you should get at least 15-20 marks more. Is it clear?
Yes, sir.
Sir, can you
Yes.
send the PDF of the question paper?
Okay, sure. After the class, do remind me. I'll send the PDF of the question paper. We'll be discussing it
Yes.
on Friday night. Okay. On Friday night, we'll discuss. Let's see, somebody else has also submitted. Khadija. Okay, Madhurjo, you also have to improve. Try to understand. Are you getting Madhurjo? You have to improve yourself. This is not the kind of score I'm expecting from you.
Yes.
Okay. So one more. So, anyways, let us start with the class. Okay. So last day we were discussing binomial theorem. Okay, can you people see my screen? Tell me.
Yes, sir.
Okay. So I think these were the homework questions. Okay. Number one is option D. Anyone having any doubt, you can ask me. Number 1 is option D.
Sir, I have a doubt in this question.
Yes. So, Ifsha, you didn't, you didn't attempt the test?
No, sir. Sir, I just came home right now. Like at 6 o'clock, I was out. I went
Out?
to give. I went to give an exam.
Acha, Allen's test.
No, physics wala.
Physics wala.
Yes, sir.
How did that test go?
It went okay.
Okay.
Paper 1 was easy, but I had faced some difficulty in paper 2.
Just send me the paper. Okay, send me the
Okay,
paper.
sir.
Let me see. And also, will you give ellipse and hyperbola later? Tell me.
Sir, I can give later. Yes.
Later. But before Friday, you have to give. Tell me, Ifsha.
Okay.
Friday, I'm going to discuss the paper.
Okay, sir.
So, when?
Sir, tomorrow or maybe Tuesday, any day.
Okay. See, I have sent the test link. Okay. Whenever you are ready, let me know. Okay. And then you can start giving the test. I've already sent the access code also.
I
Okay.
will let you know, sir, beforehand.
Sure.
Okay, sir. Thank
Okay,
you.
number 1, I'm solving it out. Okay, it is given that if r equal to 0, 1, 2 up to 10, AR, BR and CR denote the coefficient of x to the power r in the expansion of this. Okay, you need to find out this expression. Okay, so many things are given to us. Okay, we need to find out AR into B10 BR minus C10 AR. Okay, let us start.
Sir, I too have a doubt in this. My answer is coming different.
Okay, let me solve. Let me solve. Let me see what am I getting. Okay. So what is AR? First of all, let us write down what is AR, BR and C. AR and BR. Only AR and BR we are concerned with. We are concerned with only AR and BR in the expression. Okay, so what is AR? AR is equal to 10 CR, isn't it? Right, tell me, Rhythm.
Yes, sir.
AR is equal to
20 CR.
20 CR. Only we are concerned with AR and BR. Acha, no, we have to write down CR also. Because in the options we have CR. CR is 30 CR. Okay.
Okay,
So
sir.
what do we need? We need summation of r equal to 1 to 10 AR into B10 BR minus C10 AR. Okay. So let us substitute. This will become summation of r equal to 1 to 10. AR is 10 CR. Within bracket B10 is equal to 20 C 10. Okay. Minus BR is equal to 20 CR. Okay. Oh wait, why minus multiplication 20 CR minus C10 will be 30 C10 into AR will be equal to 10 CR. Right. Shesi, you also didn't send me your homework. What happened?
Sir, I didn't like.
You didn't do.
No.
You didn't wanted to do.
No, sir. I missed classes before, so I have to catch up with that videos.
I have already sent those videos in WhatsApp, isn't it?
Yes.
You can go through them.
Yes.
Okay. Don't create backlog of your backlogs also. Okay. Okay, 20 C10 common within brackets. I'm getting 10 CR into 20 CR. Okay, 10 CR into 20 CR. Okay, minus 30 C10 common summation of 10 CR whole square. Okay, this is what am I getting? So over here, is it possible to use Vandermont's identity? I think so.
Yes, sir. I did that. I used Vanderbilt identity.
Okay, let's see. 30 C10, 20 C10, summation of R equal to 1 to 10. Okay, I can write it as 10 C10 minus R. Can you understand? Tell me. 10 C10 minus R into 20 CR minus 30 C10 into summation of 10 CR whole square Okay.
Sir, we can write 10 CR as 10 CR's whole square as 10 CR 10 minus R into 10 CR, right?
10 CR into 10 C 10 minus R. Right.
Yes,
Over
sir.
here also Vandermont's identity, I guess. Okay, let's see. So how much are we getting? Over here, how much are we getting? Let's see. 10 CR, 10 C 10 minus R into 20 CR will become 30 C 10. So we are getting 20 C 10 minus 20 C 10 into 30 C 10 minus 30 C 10 into 20 C 10. What? Why is it coming 0?
I got the answer 0 2. It is there in the options.
Exactly why am I getting 0 then? Am I missing out on something?
No, sir, I got the same answer.
Then how did people get option D? Something is off. You also got same thing. I also got same thing.
Yes, sir, I got 0 2. Like,
For Vandermont's identity, shouldn't R start from 0? So we're missing out one.
Oh, yes. Wait a minute. I think so. Let's see. Over there's a mistake probably. Let's see. Just give me 1 minute. I think we need to add and subtract. Yes. See, rhythm for Vandermont's identity, it should start from 0, R equal to 0. You see.
yes, sir, yes.
Oh, this is where you made mistake. I also did the same thing. Anyways, so it is starting from R equal to 1, right? Okay, over here we have to do something. We have to do some modifications. Okay, as you can understand. Okay. Over here we have to do some modifications. So in order to start from R equal to 0, we have to add and subtract something, right? Acha, wait. Don't erase this one. Okay. Before using Vandermont's identity, we'll make some modification. R equal to 1 to this is 10. Okay. So in order for it to start from R equal to 0, there is something we need to add. That is, we need to add 10C 10. Let me see. Is equal to 20C 10. So over here we need to add 10C 10. For R equal to 0, it will be 10C 10 minus R 10C 10 into 20C0 into 20C 10. Okay, so we need to add and subtract minus 20C 10. Can you understand? This whole thing, when you want to start with R equal to 0, okay, when
Yes.
you want to start with R equal to 0, you need to subtract 20C 10, right? Because you have added 20C 10. And then you need to add 30C 10. Tell me, did you understand, Ritam? Now these two will get cancelled, as you can understand, right? Now this will become 20C10 into 30C10 minus 30C10 into 20C10. Okay, plus now this is C10. Yes, so that is how we are getting C10 minus B10. Yes. See, one small mistake. So start with R equal to 0. C10 minus B10 is our answer. Is it clear? Tell me.
Yes, sir.
Okay.
Can you please explain the subtraction and addition?
Yes. See, Vandermont's identity should start with R equal to 0. Right, so Ankit, tell me.
Yes, sir.
But over here, see, in the question, the summation is given from R equal to 1. Can you see?
Yes, sir.
Okay. So for R equal to 0, how much we should add? 20C10 into 10C10 into 20C0, right? 10C10 into 20C0 is 1. So we need to add 20C10, right? Since I'm adding 20C10 in this summation, I need to subtract 20C10. Right. Over here also we are adding
Yes, sir.
30C10 in this summation. So we need to subtract also. Minus minus it will become plus. Is it clear? Tell me.
Yes, sir. Understood.
Yes. Shreyasi, did you understand? Tell me. Oipsha, Abhigyan, did people understand?
Yes, sir.
Okay. Good problem. Okay, number two, I've got 20. Right, you people got 20? Okay, I think Vandermont's identity. I don't know. You people got 20? Option B.
Yes, yes, sir.
Yes,
Which
sir.
one?
Sir,
Which one? Tell me.
sir, I can feel that the answer is 20 but cannot solve it.
Feel. Okay. Let us solve it also. Because then NTF is also said. I feel that you should get 4 marks. But I didn't give you 4 marks. Right. Let's start. Okay. So first of all, let us write down the summation. Okay, Shubhankit. Over here, summation will be summation of R equal to 0 to 20, right? Tell me. 20CR into 20C20 minus R. Tell me. Is it clear?
Yes, sir.
This will give us 40C20. Right. It is maximum at 40C. What? It is directly simplified. R is getting. Acha, wait. R is getting cancelled. I am getting. In between, there is some mistake. Let's see. 20CR into 20C0. I have to find out in terms of R. Wait. Let me see. R then R minus 1. Acha, wait. Oh, acha, wait. 20C K equal to 0 to K equal to R. Okay. 20C K into 20C R minus K. Actually, this is the summation. Wait. Let me see. For K equal to 0, it is 20C0 into 20CR. Then 20C1 into 20CR minus 1. Yes, now it's fine. Tell me. Have you understood this summation? Tell me.
Yes, sir.
So using Vandermont's identity, it is 40CR? Tell me. And when it is greatest occurs at? It's a 2-line problem. R equal to 20. Done. Option B. Right, Shesi, you understood? Tell me. This we have done it last day? Vandermont's identity. Tell me, have you understood or should I explain again? Tell me.
Sir, would not we have to solve the summation?
No, why do we need to solve? Once you understand that it is a special form, directly write it. 40CR. Tell me. I don't think so anything is needed. If you want, I can solve it using combinatorics also. Tell me. You want me to solve using combinatorics?
Yes, sir. Can you please do it?
Okay, method 2. Let us say, suppose there are 20 boys and 20 girls. Okay, and we are supposed to select our people. Okay, suppose there are 20 boys and 20 girls and we are supposed to select our people. Okay, so what are the cases? What are the cases? Either you will select one boy or one boy. Sorry, 0 boys, R girls. This can be done in how many ways? 20CR into 20C0. Right, tell me. Or
Yes,
you'll
sir.
select 1 boy r minus 1 girl, so 20c1 into 20cr minus 1. Tell me.
Yes, sir.
Dot 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 dot. It goes on like this up to r boys and 0 girls. So 20cr into 20c0. Tell me. So what is the total? Total summation is 20cr into 20c0 plus 20c1 into 20cr minus 1 plus dot 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 plus 20cr into 20c0. Right, tell me. And tell me, what is the number of ways of choosing R people out of 20 boys and 20 girls? Tell me. Tell me, Shubhankit.
40 CR
40 CR. Understood. And when will the selection be the greatest?
at R equals to 20.
Greatest will be at R equal to 20. Right, now is it fine? Tell me.
Yes, sir.
Okay. Okay, number 4 is also a proof problem. Okay, everyone. Anyone having any doubt in 4? Tell me.
Yes, sir. I couldn't solve number 4.
Number 4. Okay, let us start.
Yes, sir.
Okay, so we have got 2n minus 2, cn minus 2, for n greater than 2. Then 2n minus 2, cn minus 1. Then we have got 2n minus 2, cn. Okay, the sum should be greater than 4n upon n plus 1. Okay, let's see. So over here, Over here, 2n minus 2, cn minus 2. Can I say 2n minus 2, cn minus 2 is greater than 1? Tell me. Greater than or equal to 1. And can I say that 2n minus 2, cn minus 1 is also greater than 1 for 1 greater than 2? And can I say that 2n minus 2, cn is also greater than 1 for all n greater than 2? Tell me.
Yes, sir.
This implies LHS is greater than or equal to 4. Tell me.
Yes, sir.
Now thinking about RHS. RHS is equal to 4n upon n plus 1. I can write it as 4 into n plus 1 minus 4 upon n plus 1, right? Which is equal to 1, 4 minus 1 by n plus 1, which is always less than 4 for all n greater than 2, right? Tell me.
Yes, sir.
Okay, so I hope you have understood.
Yes, sir.
This implies LHS is always greater than RHS.
Okay, sir.
Okay.
Means you have to prove this one by induction.
Yes, induction only. Like over here, you just have to observe what is the minimum value of the left hand side and what is the maximum value of the right hand side.
Okay.
Understood?
Okay, sir.
So number 6 is also proof. Anyone having any doubt can easily see that it is integration.
Sir, can you please solve question number 6?
6. Okay, let us start.
Yes, sir.
Yes, tell
Sir,
me.
I could not do it with integration. I did it with another process, like taking the summation sign and
Ha, I
then
understood.
multiplying, dividing.
I understood. I understood. I saw your proof. It is correct only. So let us apply integration. Let's see. C0 by 2. So first of all, you can understand we have to write down 1 plus x whole to the power n is equal to C0x. C0 plus C1x plus C2x square plus C3x cube plus dot 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 plus Cnx to the power n. At this stage, if I multiply, if I integrate at this stage, okay, what will be the denominator? Tell me. Tell me, at this stage, will we get 2, 3, 4, 5 in the denominator? What do you think on integrating? Hello, am I audible? Tell me, Oipsha, what do you
Yeah.
think?
Sir, if we integrate,
If we integrate, will we get 2 in the denominator over here? Tell me.
sir, how?
I am asking you, will we get?
Mm,
Tell me.
yes, sir.
How? When you integrate, you will see that the denominator is 1. When you integrate, you will see that you will get C0. You know how to integrate, right? Integral of C0 will be how
Yes,
much?
sir.
Tell me, what's the integral of C0? Tell me. You know this? And what is
No,
the integral of a constant? Acha, what
sir,
is the integral of x? Tell me. What is the integral of x dx? Tell me.
sir, I forgot.
Forgot. Acha, remember this. Integral of x to the power n dot dx will be equal to x to the power n plus 1 upon n plus 1. Okay.
Okay.
Remember this. Okay. So over here, integral of C0. Over here, there is nothing with C0. Means x's power is not there. So let us consider x's power is 0 over here. Okay. So
Okay.
it will be x to the power 0 plus 1 upon 0 plus 1. Right, tell me.
Yes, sir.
Are you getting Oipsha? So in the
Yes.
denominator, we'll get 1 only. At this stage, if I integrate, we'll get 1 in the denominator. Okay. But that is not we want. I mean, what do we want? We want 2 in the denominator.
Yes,
So
sir.
that means over here there should be x. Then it will be feasible to integrate. Then what will happen? Then we will get x square by 2. Right.
Yes, sir.
Okay. Now let us start multiplying by x on both sides. X into 1 plus x whole to the power n is equal to c0x plus c1x square plus c2x cube plus dot 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 plus cn x to the power n plus 1. Let us integrate. Okay. On integrating both sides, okay, we'll get. Achha, but left hand side integration, I'll tell you. On the right hand side, you'll get c0x square by 2 plus c1x cube by 3 plus c2x to the power 4 by 4 plus dot 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 plus cn x to the power n plus 2 divided by n plus 2. So see, we have got the right hand side.
Yes,
Only
sir.
we have to replace x by. Tell me how to get this expression. I need to replace x. I mean x instead of x there should be nothing. Tell me what should be replaced by x. Tell me.
1.
1 exactly. So that means we need to integrate from 0 to 1. Right, tell me.
Yes.
Okay, now the left hand side integration. Left hand side there are 2 ways to integrate. Okay, one is with substitution, another one is I guess without substitution. I think also we can integrate. Okay, so tell me, with substitution or without substitution? You know substitution by
No, sir.
integration? No, acha, okay. Okay, then without substitution, let us do it. So what I'm going to do is, I'm going to add and subtract 1. Integral from 0 to 1, x plus 1 minus 1 into 1 plus x whole to the power n. Tell me, dot dx. Understood? So this will become integral from 0 to 1. X plus 1 into 1 plus x whole to the power n will become 1 plus x whole to the power n plus 1 minus integral from 1 plus x whole to the power n dot dx. Tell me, 0 to 1. Is it clear? Tell me.
Yes, sir.
Okay. So this will become 1 plus x whole to the power n plus 2 divided by n plus 2 minus 1 plus x whole to the power n plus 1 divided by n plus 1. This we have to substitute from 0 to 1. So let us substitute. When you substitute 1, you will get 2 to the power n plus 2 divided by n plus 2 minus 2 to the power n plus 1 divided by n
So
plus
your
1.
skin is frozen.
Wait, is it okay for others?
Yes, sir.
Can you people see screen? Okay, here now is it possible? Now is it okay? Tell me.
No, sir, I'll rejoin.
Okay, rejoin. Minus 1 by n plus 2 plus 1 by n plus 1. Tell me. Is it fine?
Yes, sir.
Tell me. Okay. So let us take LCM. Minus 1 by n plus 2 plus 1 by. So over here I am going to take LCM. LCM would be n plus 1 into n plus 2. Okay. Let's see what are we getting in the numerator. 2 to the power n plus 2 into n plus 1 minus 2 to the power n plus 1 into n plus 2 minus of n plus 1 plus n plus 2. Okay, let us simplify. So over here some things will be common, right? 2 to the power n plus 2 into n and 2 to the power n plus 1 into n. So you take 2 to the power n plus 1 common. Okay, within brackets you are going to get, take 2 to the power n plus 1 common, within brackets you are going to get 2 into n plus 1, that is 2n plus 2 minus n minus 2. Okay, and over here n plus 2 minus n plus 1, that will be 1 only, right? So minus 1, actually plus 1 divided by n plus 1 into n plus 2. Tell me, is it clear?
Yes, sir.
Sure.
Yes.
You see plus 2 minus 2 gets cancelled. 2n minus 1, n will be equal to n. So you are getting 2 to the power n plus 1 into n
Plus 1.
plus 1 upon n plus 1 into n plus 2. Is this what we needed to prove? Tell me.
Yes.
Okay. So have you understood?
Yes, sir.
Okay. Remember this integration at least. Okay, at least till the time we don't start calculus. Okay. Integral of x to the power n dot dx will be equal to x to the power n plus 1 upon n plus 1. Okay, remember this. Anyways, so let us move on. Next one is summation of r equal to 0 to n r square into ncr. This one is given as n into n plus 1. This one is given as n into n plus 1 into 2 to the power n minus 2. Tell me. Anyone having any doubt, you can ask me. Next. Find the integral part of 2 plus root 3 whole to the power 6. This is given as 2701. You people got, I hope you people have got 2701. This one is given as 1. Anyone having any doubt in 8, let me know.
Sir, obviously number 7.
7.
Yes, sir.
Okay, let us start. So tell me, with differentiation or without differentiation? Tell me. Shovankit?
So with differentiation.
With differentiation. So see, I need 2 R's. Can you see? I need 2 R's. Like 1 R we know how to get it. I'll differentiate once. I'll get 1 R in front, isn't it? Tell me. Shovankit? We know how to get 1 R. Just give me 1 minute. Okay, we actually know how to get 1 R, but I need 2 R's now. Okay, so let us first of all see what is 1 plus x whole to the power n. 1 plus x whole to the power n is equal to c0 plus c1x plus c2x square plus dot 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 plus cn x to the power n. Okay, I need 2 R's, right? So first of all, let us multiply by x. Okay, we'll get x into 1 plus x whole to the power n is equal to c0x plus c1x square plus c2x cube plus dot 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 plus cn x to the power n plus 1. Okay, let us differentiate. What do we get? On differentiating left hand side, we have to use UV rule, right? We'll get nx into 1 plus x whole to the power n minus 1, okay, plus 1 plus x whole to the power n, okay. This will be equal to c0 plus 2c1x plus 3c2x square plus dot 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 plus n plus 1 into cn x to the power n, right? Tell me, have you understood, Shubhankit, up to this much?
Yes, sir.
But I need r square, right? Instead of 2, I need 2 square. Instead of 3, I need 3 square. Instead of n plus 1, we need n plus 1 whole square, right? Tell me.
It means you have to multiply it by x again.
We have to multiply by x again. Very good. You understood quickly. So n into x square. Oh, wait a minute. Nx to the power n minus 1. Is it starting with r equal to 1 or r equal to 0? R equal to 0, right? R equal to 0 to n, r square into NCR. But the problem is over here, this term will become n plus 1 whole square.
And so another thing is that r square means NCR, but here is r square becoming NC r minus 1.
Correct. Okay. Acha, so what you do is, if you put r equal to 0, this is gone. NC0 will not be there. Are you getting? So even if you remove NC0, it's not a problem. Understood, Shavankit? Even if
Yes,
you
sir.
remove NC0, it's not a problem because while putting r equal to 0, it is gone. So you differentiate in the initially only. Okay. You differentiate initially only. So what are we getting? N into 1 plus x whole to the power n minus 1 is equal to c1 plus 2c1 c1 plus 2c2 x square 2c2x plus 3c3x square plus dot 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 plus ncn x to the power n minus 1. Okay, now it's fine. So we are getting RCR. Right, tell me, Shavankit. Can you
Yes,
understand? Acha, now I need r square. So now you multiply by x. Understood? Nx 1 plus x whole to the power n minus 1 is equal to c1x plus 2c2x square plus 3c3x cubed plus dot 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 plus ncn x to the power n. Yes, now you see, now you are going to get n square. So now you differentiate, you are going to get n into n minus 1 into x into 1 plus x whole to the power n minus 2 plus n into 1 plus x whole to the power n minus 1. Tell me, is it clear, Shavankit?
yes, sir.
This will be equal to 1 square into c1x, 1 square into c1 plus 2 square into c2 x plus 3 square into c3x square plus dot 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 dot. Now instead of x, what do we need to substitute? 1. Right, put x equal to 1. I think we should get our answer. What are we getting? N into n minus 1 is equal to 1. So 1 plus 1, 2 to the power n minus 2 plus n into 2 to the power n minus 1. Taking 2 to the power n minus 1 common, within brackets, what are we getting? N into 2 to the power n minus 1 common. What are we getting? Over here, 2 into n minus 1. So 2n minus 2 plus 1. Wait a minute. It's not coming. Why? N minus 1 into n into n minus 1 into 2 to the power n minus 2 plus n into 2 to the power n minus 1. Okay. Acha, oh, 2 to the power n minus 2 is smaller. 2 to the power n minus 2 is smaller. N into 2 to the power n minus 2 common. We are going to get n minus 1 plus 2, which will give us n into n plus 1 into 2 to the power n minus 2. Let's see. This is what is given. Tell me, is it clear? Shubhankit, number 7.
Yes, sir, clear.
Okay. Number 8, 2701, then 1. Okay, 9 part 1, 3 plus root 7 whole to the power n. Okay, we need to prove that it is an odd integer. Anyone having any doubt? You can ask me now. Let's see. 3 plus root 7 whole to the power n is an odd integer you have to prove. And over here also you have to prove an even integer, 9 part 2. Anyone having any doubt in 9 part 1 and part 2? Let me know. Okay, number 10. Number 10, it came this year only. The answer is 2 to the power 100 by 101, I guess. Option B. You people got option B? Let me know. What have you people got? Option B.
Yes, sir.
Okay. So anyone else having any doubt? Tell me. Okay. So I think we can continue. Last day we were discussing. Okay. I think we have done. Okay, let us do some problems. Question number 1 for today. Find the value of half C0 minus 10C1 plus 10C2 into 2 plus 10 minus 10C3 into 2 square plus dot 10C10 into 2 to the power 9. Okay, plus 10C10 into 2 to the power 9. Once you have done it, send your answers, everyone. Question number 2. Prove that NC0 plus n plus 1 C1 plus n plus 2 C2 plus dot plus n plus r CR is equal to n plus r plus 1 CR. Okay, once you have done it, keep sending your answers. Yes, Adija, first one is correct. Rhythm, first one is correct. Question number 3. You have to find out the if summation of k equal to 0 to n k summation of k equal to 0 to n nck into k square summation of k equal to 0 to n nck, and yes, Shamili, first one is correct. Summation of k equal to 0 to n NCK into 3 to the power k is equal to 0 holds for some, yes, here first one is correct, holds for some positive integer n, then find, yes, Adito first one is correct, find summation of k equal to 0 to n NCK by k plus 1, NCK by k plus 1. Solve. Yes, Ronak, first one is correct. Okay, Oipsha, this is the answer of which one? 2 or 3? Which one? 1, 2, 3, which one?
Sir, is that a determinant in question number 3?
Yes, question number 3, this is a determinant. You people know, right, how to solve 2 cross 2 determinant. Okay.
So,
Yes, Ritam 2 is correct. Abhipsha, this is the answer of which question?
Sir, first question.
No, that's not correct.
Okay.
Shinika, check the first one. Okay, Shinika, check the first one. Adrija, second one is correct.
so in the determinant in the third question, the fourth term is 3 to the power k.
Yes, 3 to the power k.
Okay, so
Okay, let us start. First one I'm solving, pay attention. Okay, it's, see, the power of 2 is also increasing. Okay,
Hello, sir. I'm sending. Please check.
you have sent it.
Sir, I'm sending.
Oh, sending. Send.
Yes, sir. Sent it.
Wait, let me check. Okay, Shubhankit, first one is correct. Okay, everyone pay attention. So what have we got over here? It is half C0, okay, minus 10C1 plus 10C2 into 2 minus 10C3 into 2 square. Okay, let us compare it with 1 minus x whole cube, whole square, I mean whole to the power n. Okay, the only thing is that over here instead of half it should have been only C0, right? Instead of half it should have been 1. So what I'm going to do is I'm going to take half common. Okay, if you take half common, let us say n equal to this. Okay, so over here n will be equal to half common. Within brackets, what am I getting? I'm going to get C0 minus 10C1 into 2 plus 10C2 into 2 square minus 10C3 into 2 cubed plus dot 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 plus 10c10 into 10 to the power 2 to the power 10. So see, it is a binomial expansion of 1 minus 2 whole to the power 10. Can you see?
So why do you take half common?
Because when you compare it with any binomial expansion, 1 plus x or 1 minus x whole to the power n, can you see that the power of 2 is increasing to the power n? So maybe it is an expansion of 1 minus x whole to the power n. When you expand 1 minus x whole to the power n, you are getting c0 minus c1x plus c2x square. Okay, dot 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 dot. Are you getting? So when you compare, c0 should be free of any constant term. Okay, so that's why I took one half common. So this becomes half into 1 minus 2 whole to the power 10. This will give us half. Done. Is it clear? Okay. Is it clear, Avipsha? Avipsha, you have done it.
Sir, I
And
have sent the answer.
yes. I have got it. Shinika, did you understand? Tell me.
Yes, sir.
Okay. Quickly solve the second one. Yes, Adrito, second one is correct. Second one is very easy. We have done it a lot of times. Should I start? Second one? Okay, everyone pay attention. So everyone, you people tell me, instead of NC0, can I write n plus 1 C0? Tell me. Instead of NC0 on the left hand side, okay, instead of NC0, can I write n plus 1 C0? Tell me. Plus n plus 1 C1 plus n plus 2 C2 plus dot 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 plus n plus R CR. You people tell me, everyone, what is n plus 1 C0 plus n plus 1 C1? What is NCR plus NCR plus 1? Tell me, what is this? What is NCR plus NCR plus 1?
N plus 1 CR plus 1.
N plus 1 CR plus 1. So see, if you add the first two terms, you are going to get n plus 2 C1 plus n plus 2 C2 plus dot 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 plus n plus R CR. Okay, next. Now this is also in the same format. You are going to get n plus 2 C2, then n plus 3 C3, then n plus 4 C4. It keeps on going, right? After some steps, after R minus 1 steps, you are going to get n plus R C R minus 1 plus n plus R CR. Okay, so again NCR plus NCR plus 1 will give us n plus 1 CR plus 1. So n plus R plus 1 CR. Hence proved. Is it clear to everyone? Tell me. Tell me, Shana, Shashi, is it clear?
Yes.
Those who are online, is it clear? Tell me. Shashwato, is it clear?
Yes, sir.
Shamali, Shinika,
Yes, sir.
Ronak, Madhurjo, is it clear?
Yes, sir.
Anvesha, have you understood?
Yes, sir.
Okay. Move on to the third one. Should I start, everyone? Third one? Tell me. Okay, let me start. Third one. Okay, this is a determinant. Okay, I think we have to simplify this determinant. Let me see. Okay, let's see. It is given that it is equal to 0. Okay, let us start. This is number 3. Okay, so what is summation of k equal to 0 to n? K. What is the first one? First one is n into n plus 1 by 2. Right, tell me, everyone. Are you people able to identify? The next one is summation of nck k square. It's a binomial expansion, isn't it? Okay, but the binomial expansion of nck into k square. Asha, we have done it already, right? R square into ncr. Today only we did. Just now I have explained it. Summation of r square into ncr. Right. What was summation of r square into ncr? N into n plus 1 into 2 to the power n minus 2. Right. So let us substitute. N into n plus 1 into 2 to the power n minus 2. Next. The third term is summation of k into nck. This we have done it last class, I guess. Summation of r into ncr. Right. Let me see. Summation of r into ncr, we did it last class. Oh, last to last class or last class? Last class, I guess. This was summation of R into NCR, I guess, over here. I think this one. This one is summation of R into NCR. Can you see? That is n into 2 to the power n minus 1. So let us substitute. Okay. N into 2 to the power n minus 1. And the fourth one is summation of nck into 3 to the power k. Nck into 3 to the power k means what? Nc0 3 to the power 0 plus nc1 3 to the power 1. Somebody tell me what is nc0 3 to the power 0 plus nc1 3 to the power 1. What is this? What is this? Plus nc n 3 to the power n. What is this? Tell me. What expansion is this? nc, are you people able to relate with nc0 x to the power 0 plus nc1 x to the power 1 plus nc2 x square plus nc3 x cube plus
It is 4
ncn?
to the power n.
1 plus 3 whole to the power n, isn't it? So this one will become 4 to the power n.
Sir, I have a doubt in like the left lowermost corner term.
Third term, this one.
Yes, yes. Why
What?
NCK? Why NCK is n into 2 to the power n minus 1? NCK should be like 1 plus
Oh,
x to
wait
the
a
power.
minute. Wait a minute. I gave the question wrong. Sorry, everyone. Actually, it is k into nck. Sorry. Sorry. I gave the question wrong. Okay. Acha, you people try it once again. Okay. You people try. My bad. I get the question wrong. The summation of k into nck. Okay, take your time. I'm giving 2 more minutes. Solve this one. Okay, by mistake I gave summation of nck. It should have been k into nck.
Also, can you please show the full question?
Yes. Yes, over here. Okay, try. Take your time and tell me what is the answer.
Sir, will the answer come in fractions?
Answer, let me see. Might come. Yes. This is okay, this is correct. But find out the final answer. Yes, it is correct. Rhythm. Your answer is correct.
I found out the expression.
Found out the expression. This how we have to solve? We have done it already. Remember? So this can be counted manually. How?
Manually you can do.
Manually, why not?
I thought formulas.
Why not? You can do it manually. It's a small value, right? Okay, so let us start. Okay, everyone.
Sir, can you wait? I'm sending.
Send. Adija, there should be a particular value of n. Okay, you might get particular because this is equal to 0, right?
Oh, okay, sir.
So see, I'm solving it. So on cross multiplication, okay, everyone. I mean, on simplifying. But before simplifying, I think over here we can take something common. From the first row, I can take n into n plus 1 common. Can you see? From the first row, I can take n into n plus 1 common. Determinant of half, then 2 to the power n minus 2. Over here, n into 2 to the power n minus 1. And over here, 4 to the power n. From the second one also, I think I can take something common.
So 31 by 5. 31 by 5.
31 by 5? Yes, that is correct. But over here, n cannot be equal to 0 and n cannot be equal to minus 1. Right? Can n be equal to 0? No. And n cannot be equal to minus 1. So we can eliminate this one. Eliminate this factor. This implies, let us cross multiply. What are we getting? Achha, or I mean, over here also we can take something common. We can take 2 to the power n minus 1 common. So when you take 2 to the power n minus 1 common, over here in the determinant you are going to get half 2 to the power n minus 2, then n,
Can
then
you
2 to
please
the power
take
n plus 1. This is equal to 0. I think now it is simpler. We can solve it quickly. Yes, Shwankit, your answer is correct. Okay, let us cross multiply. Now, can 2 to the power n minus 1 be equal to 0? Again, you can eliminate it. I mean, we can divide by 2 to the power n minus 1 on both sides. So on cross multiplication, what are we getting? 2 to the power n minus 2 to the power n minus 2 to the power n minus 2 into n will be equal to 0. So over here we can take 2 to the power n minus 2 common. 2 to the power n minus 2 common, within brackets we are getting 2 square minus n equal to 0. Now this cannot be equal to 0, so n equal to 4, right? Are you people getting, everyone? I've got n equal to 4. After getting n equal to 4, it is easy. So you substitute. So summation of k equal to 0. Are you getting Abhigyan or Ipsha?
Yes, sir.
Okay. Anvesha, are you getting nck by k plus 1? This will be equal to summation of k equal to 0 to 4. Adrito, Ronak, Shamili, are you getting?
Yes, sir.
K equal to 0 to 4. 4ck upon k plus 1. So let us substitute. This will give us for k equal to 0, it is 4c0 by 1 plus 4c1 by 2 plus dot 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 plus 4c4. Adrija, have you understood? Divided by 5.
Yes, sir.
This will give us Let us calculate. 4C0 is 1. 1 plus 4 by 2 is 2. 4C2 is 6. 6 divided by 3, 2. 4C3 is 4. 4 divided by, over here it will be 4C2 by 3. 4C3 by 4, 1 plus 1 by 5. This will give us 6.2. Yes, 6.2 is correct. Okay. Let us start. Let us continue, everyone. Okay. Our next topic is binomial theorem for any index. Binomial theorem for any index for n belongs to rational numbers. Okay. When this is only valid, n belongs to rational numbers or negative. Rational numbers means I have taken negative integers also. Okay. When mod of x is less than 1, this is only valid when mod of x is less than 1. I'll show you one illustration why mod of x should be less than 1. Okay. Do you remember we have done this series? We have done this series in GP, 1 plus x square plus up to x to the, plus up to infinity. Right, tell me. What is 1 plus x square plus up to x to the power plus up to infinity? Do people remember?
1 by 1 minus x.
1 by 1 minus x. And what is this? This is 1 minus x whole to the power minus 1. That's the expansion of 1 minus x whole to the power n when n is a negative integer. Understood, everyone? And do you remember, infinite GP is only valid when mod of x is less than 1. Right. Next. So let us start. 1 plus x whole to the power n, number 1. 1 plus x whole to the power n will be equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x square, x cube plus up to infinity. Okay, next, if I want to find out the expansion of 1 plus x whole to the power minus n, number 2, 1 plus x whole to the power minus n, if I want to solve, this will be equal to, instead of n over here, let us replace it by minus n. So it will become 1 minus nx plus, over here if you substitute minus n, it will become minus n into minus n minus 1. So minus minus common, it will be n into n plus 1 upon 2 factorial multiplied by x square, tell me, plus, this one will be minus n into n plus 1 into n plus 2 by 3 factorial into x cube plus dot 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 up to infinity. Okay, so this is 1 plus x whole to the power minus n. Okay, next, number 3. All these expansions are only valid when mod of x is less than 1. If mod of x is greater than 1, then the series will diverge. It will never converge. So you're good. Next, 1 minus x whole to the power n. In the first equation, you replace x by minus x. Okay, so what are you getting? Put minus x instead of x in equation 1.
So for 1 plus x whole to the minus n, the terms become plus, like n into n plus 1 and n plus 1.
Yes, you see, over here when you substitute minus m, you are getting minus n into minus n minus 1. So when you take n minus common, you are getting n plus 1. You see? Are you able to visualize it? Tell me, Shania. Shesi, are you getting? Tell me. Okay. Next, 1 minus x whole to the power n. This will become 1 minus nx. Okay. Plus n into n minus 1 by 2 factorial into x square minus dot 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 up to infinity. Number 4. Okay. Now this fourth one is very important. Okay, you have to remember it by heart. Okay. 1 minus x whole to the power minus n. Okay, that is in the first equation and in the first equation you have to replace x by minus x and n by minus n. You are going to get 1 plus nx plus n into n plus 1 by 2 factorial into x squared plus n into n plus 1 into n plus 2 by 3 factorial into x cube dot plus dot 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 plus up to infinity. Tell me. Abhigyan, are you getting? Tell me. Abhigyan, Madhurjo, are people getting?
Yes, sir.
Pratyay, are you getting? Samragni, are you getting this?
Yes, sir.
Abhipsha, are you getting?
Yes, sir.
Okay. Shashwato, can you understand?
Yes, sir.
Okay. Samragni, are you getting? Tell me.
Yes, sir.
Over here, if I ask you what is the coefficient of x to the power r in 1 minus x whole to the power minus n, what is the coefficient of x to the power r? Tell me. Somebody tell me, raise your hand. What is the coefficient of x to the power r? Identify. Tell me. What is the coefficient of x to the power r in this expansion? Raise your hand and tell me. Yes, Ritam, tell me.
Sir, n into n plus 1 into n plus 2 dot 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 n plus r divided by r factorial into x to the
You
power
are making a mistake.
N plus r minus 1.
Exactly. It should be n
n
plus
r
r
minus 1 till r minus 1.
divided by r factorial. Right, tell me. Okay. N into Adrija, do you remember this? On Friday we did.
Yes.
Adrija, Ahir, do people remember? Okay. N into n plus 1 into n plus 2 up to n plus r minus 1 divided by r factorial. Okay, but see, the numerator is incomplete, right? We have to multiply some terms. If we multiply some terms to make it factorial, what should we multiply? N minus 1 whole factorial, right?
Yes.
Okay, so let us multiply by n minus 1 whole factorial. Okay. And in the numerator, we'll get this. Okay. So, since we are multiplying by n minus 1 whole factorial in the numerator, we have to multiply by n minus 1 whole factorial in the denominator as well. So, this becomes n plus r minus 1 whole factorial divided by r factorial into n minus 1 whole factorial, which is nothing plus but n plus r minus 1 cr. Okay. Remember, this is the coefficient of x to the power r in 1 minus x whole to the power minus n. It's very important. Binomial theorem for any index. Okay. Okay, question number. Huh?
You taught on Friday.
Friday, it was a doubt class. Okay.
Didn't take it.
No, nothing. Question number 4. Find the range of x. Find the range of x for which 8 plus x whole to the power 4 by 3 is valid. Question number 5. Find 8th term in the expansion of 1 plus 2x whole to the power minus 8. Question number 6. Find the coefficient of x to the power r, x to the power 100 in 3 minus 5x into 1 minus x whole to the power minus 2. Solve. Keep solving, everyone. Question number 7. Find the term independent of x in the expansion of 1 minus x upon 1 plus x whole square. Solve. Yes, here number 4 is correct. Ritam, number 4 is correct. Adrija, there is a slight mistake. Shinika, 4 is correct. Ritam, you have to find out the 5th term. Okay, you are making a mistake.
Sir, you have written 8th term.
Oh, 8th term. I mean, you need to find out the 8th term, not just the coefficient. Ronak, number 4 is correct. Adrito, there is a slight mistake in number 4. Okay, Ritam, check number 4. No. I mean number 5. Adrija, check number 4. Okay, let's start with 4, everyone. Okay. So when will the expression, when is the expansion, over rational index valid? Okay, let us recall. 1 plus x whole to the power n, remember, 1 plus x whole to the power n is only valid when mod of x is less than n, right? But over here it is written 8 plus x, right? So I need to convert it into 8 plus x, 1 plus x. So what I'm going to do is I'm going to take 8 common. Okay, everyone? I'm going to take 8 common over here. This is number 4. So taking 8 common, we'll get 8 to the power 4 by 3 within brackets 1 plus x whole to the power 4 by 3. Okay, so this expansion is only, within bracket x by 8. So this expansion is only valid when mod of x by 8 is less than 1. This implies x should be less than mod of x should be less than 8. This implies x lies between minus 8 to 8. Is it clear to everyone? Tell me. Then only this expansion is valid. Yes, Madhujo, number 6 is correct. Madhujo, have you understood number 4?
Yes, sir, I have.
Okay. Yes, Adrito, 5 is correct. 4, have you understood, Adrito? Yes, Ritam, number 6 is correct. Okay, Adrija, check number 5. Adrija, have you understood 4?
Yes,
Sir,
sir.
yes, I'm fine.
Okay, number 5. I haven't got the answer in this form, but no, I think I will check number 5. Okay, Ritam, check number 5. So let us start.
So number 5.
Sir, wait a minute. Okay, I think Ritam, your answer is correct, I guess. But let me see. Wait, let me see. Okay, let me solve number 5. Wait, you have done it. Let me see. Okay, I think it is correct. Let me see. Okay, wait, I'm solving everyone. Okay, I think over here the answer is given wrong. Wait, let me solve. 1 plus 2x whole to the power minus 8. Let me solve. We need to find out the 8th term. This is number 5. Okay, so 8th term will be equal to 8th term will be equal to t7 plus 1. R equal to 7, right? Over here.
Yes, sir.
Okay. R equal to 7. Okay. So it is 1 plus x whole to the power. Okay, coefficient of x to the power 7. So coefficient of x to the power 7 will start with n into n minus 1 into n minus 2. It is power is minus 8. So this one. N into n plus 1 into n plus 2 into n plus 3 up to 7th term. 7th term means divided by, it should be 7 factorial. Okay. Okay, let us start. So it is minus 8 n into n minus 1. So minus 9 into minus 10 into minus 11 dot 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 up to minus 13, I guess. N plus r minus 1 divided by r factorial. So 7
Sir, there
factorial.
also should be minus 14.
Should be. Minus 14 will be there. Let me see. N into n minus 1 into n minus 2 up to. For 8th term, na? For 8th term, it will be n plus r minus 1. So n.
So general term is n plus 1 into n plus 1.
N minus r plus 1. So minus 8 plus 1. N minus 7. Okay. So minus 14 divided by 7 factorial into 2x whole to the power 7. Right, tell me.
Yes, sir.
Oh yes. So total over here there are how many terms? Even or odd number of terms? Tell me. In the numerator, odd number of terms, right? So it will be negative. Negative. But in order to complete it, let us multiply by 7 factorial divided by 7 factorial. So it is 7 factorial into 14 factorial divided by 7 factorial into 7 factorial. Okay. Into 2 to the power 7 into x to the power 7. So 14 factorial. So
Yes,
actually
I do this,
it
but
will be
I
14
forgot the
factorial.
negative.
So minus
Yes, sir.
14c7 into 2 to the power 7 into x to the power 7. Those who have got this answer is correct. Okay, by mistake I told you wrong. Okay, those who have got this answer, they are correct. Over here the answer is given wrong. Anyways, this was number 5. You people try number 6. Everyone understood number 5? Tell me. Yes, Oipsha, you have got it correct. Oipsha, okay, it is correct only. Okay. Abhigyan, did you understand? Abhigyan, Shwankit, did you people understand? Tell me.
Yes, sir.
Yes, sir.
Okay. Number 6. Yes, everyone solved 6 quickly. In 1 or 2 days, I'll complete binomial. Okay, I think binomial will be completed in 1 or 2 days. So
The
another
next
test.
chapter is complex numbers.
Next chapter is complex numbers. So soon another test is loading. Okay. It might happen by the end of Feb. Okay.
So further our exam is ending, where will you study?
Oh, sir. So after Ritam's exam ends, okay, Ritam's exam is going to end on 28th Feb, I guess.
Mine is on 26th.
No, sir, it's 23rd February.
How much?
23rd February.
23rd.
Mine
Okay.
is 26th.
So you can take the test on 29th February.
29th, yes.
In 3 days
So,
I'll study.
no. So
Sir,
smart. 29th Feb. See?
Sir, my exam ends on 5th March.
Okay. Actually, I think somebody's exam was supposed to end on 28th Feb. I think it is
Sir,
Shashwato.
mine.
Shashwato, yes. After 28th Feb, another test, binomial, in the first week of March only, I guess. Let's see. So keep practicing, everyone. Okay, next, let us solve number 6. We need to find out the coefficient of x to the power 100. Let us start. Yes, Adito, your answer is correct. Adrija, your answer is correct. Okay, Ritam. Ritam, number 7 is correct. Okay. Adito, your exam has ended.
Yes, sir.
Okay. Next, number 6. Everyone pay attention. 3 minus 5x into 1 minus x whole to the power minus 2. Okay. So this will become 3 into 1 minus x whole to the power minus 2 minus 5x into 1 minus x whole to the power minus 2. In order to find out the coefficient of x to the power 100, over here, what is coefficient of x to the power 100? N plus r minus 1, that is 2 plus 100 minus 1 c 100. Right, tell me, n plus r minus 1 c r minus. Over here, if I want to find out the coefficient of x to the power 100, I need coefficient of x to the power 99 over here, right? So 2 plus 99 minus 1 c 99. Tell me, this is your answer. Okay, this will give us how much? 102, 101, actually 3 into, and this is also 5 into. So 3 into 101 c 100 minus 5 into 100 c 99. I hope you people can understand. This will give us 303 minus 500. That is minus 197. Very simple. I hope it is clear to everyone. Next. Quickly solve number 7, everyone. Quickly solve. Okay, let us start. We need to find out the term independent of x in this expansion. Okay. So let us start. Okay, not this one. 1 minus x upon 1 plus x whole square. Number 7. Okay. Yes, Adrija, right answer. 1 plus x whole square. This is nothing but 1 minus x whole square into 1 minus x whole to the power minus 2, which is equal to 1 minus 2x plus x squared multiplied by 1 minus 2x plus
1 plus x whole to the power minus 2.
fine only. What?
So
Couldn't.
the denominator is 1 plus x whole to the power.
Oh, achha, okay. So 1 plus 2x then. 1 plus 2x plus 2 into 2 plus 1 divided by 2 factorial. That is 2. 1 plus 2x plus I think 3x square. Whatever it is. Plus dot. Okay. Now the point is over here there is only one term independent of x. When the first term of both the expressions are multiplied. So term independent of x it will be equal to 1. Are you people able to understand? Tell me. Term independent of x will be equal to 1. Okay. Next. Our next topic is.
Sir, I have joined the class just now.
Yes. Good evening, Joyatra. Why so
I,
late? What
sir,
happened?
I had a mock test, so I got late from coming from that.
Okay. I'll upload the video. See it.
Okay.
Okay. Our next topic is generating functions. Okay, everyone, pay attention. Generating functions and how it can help us in counting. Okay, pay attention. So first of all, let us write down the definition. Let AR is equal to A0, A1, A2, dot. Somewhere in between you will get AR, dot. It goes on like this. Be a sequence, be an infinite sequence of numbers. Okay, be an infinite sequence of numbers. Sequence of numbers. Okay, the generating function of the sequence AR is defined as the polynomial of infinite degree as the polynomial of infinite degree okay as the polynomial of infinite degree AX, which is equal to summation of R equal to 0 to infinity AR x to the power R. Okay, R equal to 0 to infinity AR x to the power R. Okay, let us expand, you will understand. It is equal to A0 plus A1x plus A2x square plus dot plus up to infinity. Okay. How we can apply generating functions? How can generating functions help us in counting? Okay. Application of generating functions. Application of generating functions. Okay. So for large number of selection of objects, or large number of selection of objects, we use generating functions. Okay. And it is more concrete than counting. Okay, than manual counting. Okay, everyone. So over here, what we'll do, we group alike objects together, and with each group we define a variable representing number of objects that can be selected, from the group, then we add all the variables. Okay, means we'll define each and every variable to the number of objects we are going to select. Okay, so I'll give you an example, you'll understand. Then we add all the variables and equate the sum to the total objects to be selected, Okay, so I'll give you an illustration, you will understand. Okay, illustration. Okay, some of the numbers on throwing two dices. Okay, on throwing two dices. Okay, so how I am going to write down the generating function, pay attention. Okay, and how I am going to relate it, you will understand. Okay, so somebody tell me, whenever you roll a dice, what are the outcomes? When we roll a dice, what are the outcomes?
1 to 6.
1, 2, 3, 4, 5, 6. These are the outcomes, right? Next. So let us take f of x, sum of two. Let us take f of x is equal to x to the power 1 plus x squared plus x cubed plus x to the power 4 plus x to the power 5 plus x to the power 6. Okay, multiplied by the same thing. Okay, multiplied by the same thing. Okay, now why I have taken this function only? Like you people might be, might have a question. Okay, like a question can raise in your mind, why I have chosen this function only? Okay, I could have taken something else also, right? Okay, you will understand after some time. Okay, pay attention. Okay, so I'm going to manually multiply. Okay, let us manually multiply. When you multiply x with all these functions, you are going to get x square plus x cube plus x to the power 4 plus x to the power 5 plus x to the power 6. Next, when you multiply with x square, you are going to get x cube plus x to the power 4. Oh, x to the power 7 will also be there, plus x to the power 5 plus x to the power 6 plus x to the power 7 plus x to the power 8. Next, when you multiply x cube with all of them, you are going to get x to the power 4 plus x to the power 5 plus x to the power 6 plus x to the power 7 plus x to the power 8 plus x to the power 9. Tell me, Shashi, are you getting? Tell me, Shashi, Shanaya, are people getting? Next, plus x to the power 5 plus x to the power 6 plus x to the power 7 plus x to the power 8 plus x to the power 9 plus x to the power 10 plus x to the power 6 plus x to the power 7 plus x to the power 8 plus x to the power 9 plus x to the power 10 plus x to the power 11. Lastly, plus x to the power 7 plus x to the power 8 plus x to the power 9 plus x to the power 10 plus x to the power 11 plus x to the power 12. 10. Okay, this is the whole function, right? After multiplication, tell me. Asha, now you people tell me, in total, without adding, okay, don't add. Without adding, how many terms are there? What do you think? Without adding. Okay, consider x cube and x cube as separate terms. In total, how many terms are there? Tell me.
36.
36 terms are there. And what is the total number of outcomes when you roll 2 dice? 36. Same thing, right? Okay, are you people able to relate a little bit? Okay, next. You'll be able to relate it a little bit more. Okay, when you understand what is the sum of the total when you roll 2 dice? When you roll 2 dice, what is the maximum sum total? 12. See? Okay. The highest power in the whole polynomial will be 12 only. Okay. Can you get the sum below 2? No. So see, the lowest degree is 2. Okay. Next. So everyone, over here, if I ask you, in how many ways? If I ask you what is the coefficient of x to the power 4, tell me. Coefficient of x to the power 4 is equal to 3, right? Tell me. Here we can see that the coefficient of x to the power 4 is equal to 3. Right? Tell me everyone. Coefficient of x to the power 4 is equal to 3. Okay. And in how many ways? And we can get the sum equal to 4 also in 3 ways. Right, tell me everyone. In 3 ways we can get the sum total equal to 4. You see, 1, 3, 2, 2, and 3, 1. Yes or no? Tell me. These are the 3 ways in which you can get sum total of 4. Right, that's how we are getting coefficient of x to the power 4 also. By multiplying x by x cube, then x squared by x squared, then x to the power 3 by x. Tell me, are you people getting? So basically the coefficient of x to the power 4 will give us the number of ways in which you can get a sum total of 4 in rolling 2 dice. Are you people able to relate? Tell me why I have taken this generating function for rolling 2 dice. Next, if still you are unable to understand, what you can do is, okay, you can ask yourself this question, okay, like how to generate, you will understand. So note it down. Whenever you roll 1 dice, okay, whenever you roll 1 dice, you can get either 1 or 2 or 3 or 4 or 5 or 6. Okay, like this you can write on the generating function, right? If you are getting 1, that is x to the power 1. If you are getting 2, x squared. If you are getting 3, x cubed. If you are getting 4, x to the power 4. If you are getting 5, x to the power 5. If you are getting 6, x to the power 6. Okay, like this you can generate the whole function. Okay, means the powers constitute constitute all the possibilities that can happen in an event. Okay, everyone, the power constitutes all possibilities that can happen in an event. Is it clear to everyone? Tell me. Shania, is it clear? Let us take.
What if there were coins, say head tails?
Head tails? So yes.
What will it happen?
So what you do is you can take 0 and 1 instead of head and tail. You assign 1 to head and 0 to tails. Like
X
that.
plus 0 and thing will be 1.
Exactly, x to the power 0, x to the power 1. Understood?
Okay.
So whenever you multiply x to the power 0 and x to the power 1, okay, if you multiply it twice, What are you getting? Tell me.
1 plus x whole square.
1 plus 2x square. 1 plus 2x plus x square. Right.
Yeah.
This is what you are going to get. Tell me. So if I ask you, find the number of ways in which you can get two tails. Only one. That will give us coefficient of x to power 0. Find the number of ways in which you are getting at least one head and at least one tail. Means you should get both the powers 1 1 only. Right. So 1 into 1 1, power should be equal to 1. Right.
Yeah.
That gives us 2. There are two ways in which you can get at least one head and at least one tail. Are you able to relate?
Yes.
I'll give you another example, you'll understand.
I have a doubt. Like,
Yes,
if
tell
we
me.
toss 4 coins simultaneously, then we will get powers like x to the power 3. Now, x to the power 3 can also be made by 3x to the power 1 or 2x to the power 1 and 1. Like, it can be made from different possible combinations. Then how will we?
Exactly. You are correct. So over there, try to understand. We can find out the number of ways a certain event can happen. Not all possible events that you are going to define, because heads and tails are not associated to a unique number in
Okay.
counting. Are you getting?
Yes.
They are not assigned to a unique number in counting. But over here, dices are assigned to a unique number in counting. So over here, we can apply because we are getting sum total. Are you getting? I'll
Yes.
give you another example. Do you remember in beggar coin method, we have done that there are 3 beggars, B1 plus B2 plus B3. Okay, and we have to distribute how many coins? 10 coins. Okay, these are okay. So now you people tell me, if I am about to distribute 10 coins. Okay, you have 10 coins in hand. You have to distribute 10 coins to B1, B2 and B3. What is the number of ways to distribute 10 coins to 3 beggars?
12C2 without any limit.
Without any limit, 12C2. Okay. So over here, B1, so what are the possibilities for B1, B2 and B3? Okay, let us see. So it might happen that B1 has got 0 coins. Right. It might happen that B2 has got 1 coin. It might happen that B3 has got, B1 has got 2 coins, ... It might happen that B1 has got 10 coins. These are the cases. Tell me. X bar 0 plus x bar 1 plus x square plus up to x bar 10. Okay. B1 has got 0 coins. It might happen that B1 can get 1 coin, or it might happen that B1 can get 10 coins. So I've taken all the possibilities for B1. Okay. Next. Similarly, let us take all possibilities for B2 also. Right. Same thing can happen with B2. Same thing can happen with B3 also. Right. Tell me. Next. So what is the polynomial? Polynomial is x bar 0 plus x bar 1 plus up to x bar 10. Right, whole cubed. Tell me. Okay, which will give us.
So we won't have a different variable for B2 and B3.
Why? Same variables. Okay, because we are concerned about power. We are not concerned about the variable.
Sir, in this.
Wait. Rhythm, wait. Just give me.
So if it's like from 10 balls with 3 different colors, you need to choose 3 like this.
Achha, see, you are distributing alike objects. You are not distributing different objects. Are you getting?
Okay, so this is only for alike.
Alike objects. I have taken alike objects only, right?
Okay.
You are distributing alike identical coins. You have distributed. Understood, Shana?
Yes.
Shesi, are you getting?
Yes.
Tell me, Rhythm, now. What doubt you have? Tell me.
Sir, like, can't we convert it into a GP series like that?
It is converted. Currently, I'm going to apply GP series only. Okay. So after applying GP series, what are you getting? 1 minus x to the power, how much? 11
11.
upon 1 minus x, right, whole to the power 3, isn't it?
Yes.
This will give us how much? 1 minus x to the power 11 whole cubed into 1 minus x whole to the power minus 3. Tell me, is it clear? This is the function, this is the generating function for this equation. Tell me. And over here, what do we need? We need the coefficient of x to the power how much? Tell me. Over here, we need the coefficient of x to the power how much? Tell me.
10.
10? Right,
Yes.
because sum of all the coins should be 10 only, right? It cannot exceed 10. You have 10 coins in your pocket. Right, sum of all the coins should be 10. Now here we need. So let us see how I mean coefficient of x to the power 10 is forming in this equation. Here we need coefficient of x to the power 10. Tell me, are you people getting? Shashwato, are you getting?
Yes, sir.
Shashwato, I hope you are not watching a match behind the screen. Tell me. Or did I caught you?
No, sir.
That's good. Okay. So 1 minus 3x to the power 11 plus 3x to the power 22. Okay. Minus x to the power 33. Multiplied by 1 minus x whole to the power minus 3. Right. This is the function. I need the coefficient of x to the power 10. Okay. So let us multiply. 1 into 1 minus x whole to the power minus 3. Next. Minus 3x to the power 11 into 1 minus x whole to the power minus 3. But why will I multiply this? Like, is it required? Tell me. Is it required? I mean, over here we will get all the powers above 11. Tell me, are you people getting? If I multiply these two, we'll get all the powers above 11. So it's not required only. Okay, so we don't need to multiply. Don't multiply. Okay, next. Should I multiply the third term with 1 minus x whole to the power minus 3? No, again, it's not required. It's unnecessary. Okay, useless. And the fourth term, should we multiply x to the power 33 with this one? No, higher powers are not even required because we don't have that much coins. Now tell me, what is the coefficient of x to the power 10 over here? Minus 1? C 10 minus 1. Oh, C10. Right, 10 plus r minus 1, CR. This will give us how much? 12 C10. That is 12 C2. Tell me, are you people getting? Another way of using beggar coin method. Okay, without using beggar coin method. Tell me. Completely by generating functions, and this is more concrete. Okay, it's totally algebraic. Okay, no manual counting. Tell me, anyone having any doubt, you can ask me now. Should I give another example? Tell me. Or you people have understood? Tell me. Ohipsha, is it clear? Ohipsha, Abhigyan,
Yes, sir.
Adrija, Madhurjo, Ronak,
Yes, sir.
Yes, sir.
and Vesha, is it clear? Tell me. Or should I give another example? Tell me.
Yes, sir, it is clear.
It's clear.
So generating function is only for alike objects.
Well, generally only for alike objects it will come. If it comes distinct, then you take different variables. After that you have to multiply. Understood? When you are taking separately for separate variables, you find out the separate binomial coefficient and then you multiply. Understood? Manually. Okay, Joyatra, is it clear? Joyatra, Pratyay, Ronak,
Yes.
Samragni, Shubhangi, is it clear? Shamali, Shinika,
Yes, sir.
is it clear?
Yes.
So
Yes.
let us
Yes,
do
sir.
one problem on generating functions. I think next class I'll complete this chapter on Wednesday. I think so. Question number 8. Let us do one problem. Find the number of ways. Find the number of ways in which a sum of 5 can be obtained in rolling 3 dice. Solve. Find the number of ways in which a sum of 5 can be obtained in rolling 3 dice. Once you have done it, send your answers. Okay, one more. Question number 9. Question number 9, you people have to send me the full solution, okay? Because, okay, send me the full solution. Question number 9. Okay, find the number of ways. Find the number of ways in which, yes, so there is a right answer, in which 30 marks can be allotted to 8 questions. If each question carries at least 2 marks, solve. If each question carries at least 2 marks. Yes, but Ritam, I need the full solution because this sum can be done by beggar coin method also. Okay.
I mean the written solution, not the answer.
Now I need to see that you have used generating function.
Okay, sir.
Okay, Ritam, check number 8. Okay, 8 I am solving, everyone. Pay attention. Let us start making generating function. Yes, Shamri 8 is correct. Adrito 8 is correct. Okay, I am using generating function, everyone, for 8. What will be f of x? X 1, yes. Abhipsha right answer, 1 plus x squared. Anvesha number 8 is correct. Plus x cube plus up to x to the power 6 whole to the power 6. Right, tell me. 1 plus x squared plus x cube plus up to x to the power 6 whole to the power 6. Oh, wait. It should start with x. It's a dice. X plus x squared plus x cube plus x power 4 plus x power 5 plus whole cube. Okay. So this will become how much? This will be, first term is x, 1 minus r to the power n divided by 1 minus x whole cubed. Tell me, are you people getting? This will be x into 1 minus x to the power 6 upon 1 minus x whole cubed. this will give us, okay, first of all you take x cube common, x cube into 1 minus x to the power 6 whole cubed into 1 minus x whole to the power minus 3, right? Tell me everyone. Okay, that means we need, this implies we need coefficient of x square in the remaining expression, because I have already got x cube, right? Coefficient of x square in 1 minus x to the power 6 whole cubed into 1 minus x whole to the power minus 3. Okay, so this will give us, let us expand, this will be 1 minus 3x to the power 6 plus 3x to the power 12 minus x to the power 18 multiplied by 1 minus x whole to the power minus 3. Tell me, are you people getting? Yes or no? Yes, Adrija, your answer is correct. Number 9. Yes, Ahir, your process is correct. Can you can you write down the answer finally? So when you multiply, this will give us 1 into 1 minus x whole to the power minus 3. Next, should we multiply this and this? Tell me, is it required? Not required, because we'll get higher powers. This is also not required. This is also not required. We just require this. So what is the coefficient of x square? Therefore, this implies coefficient of x square will be equal to 3 plus 2 minus 1 c2. This will give us how much? 4c2. 4c2 is equal to 6. 6 is your correct answer. Tell me. Ritam, is it clear? Tell me. Ritam, Shashwato, is it clear? Madhurjo, Ronak, Shubhankit, is it clear? Jayatra, is it clear?
Yes, sir.
Yes, sir.
Okay. Okay, I think you are making a slight mistake, Ahir. Okay, quickly solve the last one, everyone. Number 9. Take your time, but it should be correct.
Sir, I changed my answer.
Okay, let me see. Yes, now it is correct, Ritam. And Ahid also, your answer is correct. Quickly solve. The last one. You people should be able to solve. Okay, let us start. So everyone, over here, there are how many? 8 questions are there, right? There are 8 questions. Number 9. Okay, that means x1 plus x2 plus up to x8 should be equal to 30, and everyone should get how many marks? At least 2 marks, isn't it? At least everyone should get 2 marks. So after getting 2 marks, now the whole equation, give 2 marks to all of them already. What are we getting? The whole equation changes to x1 will change to x plus x1 plus x2 plus dot 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 plus x8 is equal to 14, right? Now others can get any marks they want, right? Others can get any marks they want. Okay, so everyone pay attention. Okay, therefore the generating function will be equal to, the first question can get either 0 marks, or 1 marks, or 2 marks, or up to 14 marks, right? Like this, the second question can also get the same thing. So multiplied by whole to the power 30. Oh no, sorry, 8, right? Because there are 8 questions. Is it clear to everyone? This will be the generating function. Now what do we need? We need the coefficient of, here we need the coefficient of
X bar 30.
x bar 30. Okay, so let us simplify. This will give us how much? Okay, 1 minus x to the power 15 upon 1 minus x whole to the power 8. This will be equal to 1 minus x to the power 15 whole to the power 8 multiplied by 1 minus x whole to the power 8 minus 8. Okay, tell me, Shnash, Yasi, is it clear?
Yes.
Joytra, Pratyay, is it clear?
Yes.
Sir, can you show me the question once again?
Yes. Abhiksha,
Question.
Samragni, are you getting?
Uh,
Yes,
Yes,
sir.
sir.
Okay.
Sir, where
Ronak,
each question is allotted at least 2 marks. So why are we? I didn't get the solution.
okay. Each question should all should get 2 marks at least, right? So I've already given 2 marks in the beginning.
So how then we should start with x to the power 2, right?
You want me to start with x to the power 2?
Yes, like that's
Okay,
how we get.
okay, let us start with x to the power 2. No problem. I can start with x to the power 2. I can start with x to the power 2. I don't have. So x square plus x cube plus x to the power 4 plus dot 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 dot. What is the maximum marks a particular question can get? Tell me.
Sir, 30.
X to the power 16? Tell me.
Yes.
It cannot get more than 16. If you are putting x to the power, x to the power something else. Okay. Try to understand.
Okay.
You cannot get
Okay.
more than 16. Okay, because if one of the question gets 17 marks, okay, then it violates the condition that each and
Okay,
every
sir.
question should get at least 2 marks. Is it clear? Hold to the power 30. Hold to the power 8, sorry. Okay, now over here we need coefficient of x to the power how much? 30. Okay, so what I'm going to do is I'm going to find out the coefficient. Okay, so it will become x square into 1 minus x divided by 1 minus x whole to the power 8. This will give us how much? X to the power 16 into 1 minus x whole to the power 8 into 1 minus x whole to the power minus 8. Tell me, is it clear?
Yes, sir.
Wait a minute, I think I'm making a mistake. Total, how many terms are there?
Sir, I took till x to the power 30 and then the answer came right. I mean,
50.
the,
That way also it is correct, I guess. I don't think so. It's a mistake because ultimately you are seeing that how many ways you are getting x to the power 30 marks.
my confusion was that I had added till 30, x to the power 2, x to the power 3, and then up till x to the power 30. And then I did, and in that way, I got the answer. I couldn't see
Yes,
how I can.
that way also it is correct because actually you are forming, you are actually finding out the number of ways. The sum total of all the question is 30.
Yes,
Are
sir.
you getting? That is
Means
also
the
correct.
cases where more than x to the power 16 are being received is being cancelled out already.
It's being cancelled out already. Okay, so that is why I'm telling you that this process is more concrete.
Yes.
Understood? Okay, so let us simplify. Now, what my task is to find out. Wait a minute. This is x to the power 15 whole to the power 8. Okay, now my task is to find out the coefficient of x to the power 14 over here, right? Okay, this will become x to the power 16 into 1 minus 8c1 into x to the power 15. Okay, dot 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 into 1 minus x whole to the power minus 8. Now tell me, do we need this power? No, we don't need. So we just need to multiply 1 with this one. Okay, we'll get x power 16 into 1 minus x whole to the power minus 8. Tell me, Abhipsha, are you getting? Abhipsha, Abhigyan, Shamili, Shenika, Samragni, Anvesha, Adrija, are you getting? So
Yes.
here,
Yes.
Shubhankit, are you getting? X power 14 will be equal to 8 plus 14 minus 1 C14. This will be equal to 21 C14. This is your answer. Okay. And if you check your copy, you must have got this answer only when we did beggar coin method. Okay. Okay, so everyone, I think we can keep it till now. Next day, we'll do some more problems on generating functions. and probably I'll complete this chapter. Okay, 2-3 topics are left, not much. Okay, then we'll start with complex numbers. Okay, so everyone, we can keep it till now. Next class will again continue. Thank you, everyone. Bye. Good night.
Thank you, sir. Bye.
Thank you, sir.
Thank
Good
you,
night.
sir.
Thank you, sir. Good night.
Thank you for the night.
Good night.